Hi everyone, this is Professor Sebastian. We're back with our statistics class notes. We are now on page 27 of your class notes and we're starting chapter 3, numerical summaries of center and variation. So remember that chapter 2 was what I call the summarize and visualize chapter. So we learned how to summarize and visualize, first visualize either numerical or categorical data, summarize visualize numerical data through histograms, dot plots, or stem plots, and then summarize numerical data with shape, center, and spread. And then with categorical data, we visualize that data with either a bar graph or a pie chart. And then we summarize it with mode and variability. So please refer back to chapter 2 to make sure you completely understand those. In chapter 3 now, we're getting into numerical summaries of center and variation. Okay, so summaries for center and spread in symmetric distributions versus skewed distributions. That's one of the main topics of this chapter. Other summaries for variation, including variance and range. Then the empirical rule and z-scores. Then box plots, 5-number summary and outliers, and then comparing distributions. So in section 3.1, we're going to learn about summaries for symmetric distributions, which means we're talking about numerical data. And we're talking about a nice symmetric distribution, which has a nice sort of well-defined center, and then the left and right side look about the same. Okay, so the measure for the center, which again I've talked about is really kind of the balance point for a symmetric distribution, is to use the mean, or maybe many of you have called it the average before and probably are comfortable with that. The measure for the horizontal spread is variability. Measure for horizontal spread, which is also variability, which means what differences do we see in the data. That measure is going to be the standard deviation. Okay, so appropriate measures. Recall, when we're dealing with numerical data, you need to describe the distribution using 3 characteristics: shape, center, and spread. So remember that shape is either symmetric versus skewed, and then are there modes? So we see more than one mound. If there's one mound, it's unimodal. 2 is bimodal. If there's more than 2, we call it multimodal. And then outliers. Are there any data points that seem to be far away from all the others? And then center is the typical value. So in other words, if somebody said, what's the typical value for your data set? What they're asking for is what's the average in this case. And then the spread is horizontal variability. In other words, we're talking about how far away the different data points are from each other. Remember, the x-axis is numerically ordered, right? We know the x-axis, it has a number line, it's ordered, so we want to know if there's data points that are a long way from each other or are most of them close to each other. Okay, so the mean. Let's talk about the mean first, the measure for the center. This again can be thought of as the balance point of the distribution. The mean, it's a measure of choice for the center of symmetric distributions. Okay, example 28. This is a dot plot, a fictitious distribution of ACT scores for a sample of students. And I'm not computing the mean yet. I'm just kind of showing you where it does balance. There's actually a numerical computation for that we'll talk about in a second, but that's the mean. And hopefully everyone understands, if they kind of follow this with their mind's eye, that looks like we have a nice symmetric unimodal distribution, and there really is no outliers here. There's no data points that are far away from all the rest. So the good measure of a typical value in this case would be the mean.